want to speak. So question 1, the average speed of a runner in 400-meter race, okay, is 8 meters per second. So the average speed of a runner in a 400 meters. So it means that the distance in question is 400 meters, and the average speed, V average, we are told is 8 meters per second. How long did it take the runner to complete the race? Oh, I think this is a very simple question. So over here, we are looking for the time. How long? Average speed, V average, is equal to total distance over the total time taken. This is one aspect of it. So if I'm looking for time, when I make time the subject, I have the distance over the average speed. And so 400 on 8 must give you the time that will be used. This is 5. So 50 seconds is the time needed for this race. Okay, so the obvious answer there is the second one. So this is a simple question. Then question 2, which graph best represents the relationship between velocity and time for an object that accelerates uniformly for 2 seconds, then moves at a constant velocity for 1 second, moves at a constant velocity for 1 second. So this is constant velocity. And finally decelerates for 3 seconds. T3. 3 seconds. Okay. Now, we are not given much information about the initial velocity, the value of the uniform acceleration, and all that. But if we are to sketch such a motion, whether the body starts from rest or does not start from rest, and when we look at the graph, the 4 graphs, none of it indicates that the body starts from rest. So even when velocity or this speed time graph, even when I have to start from initial velocity x meter per second, I'm told that it accelerates uniformly for 2 seconds. So from this result must be 2. And this is the point where we had a uniform acceleration, which must connect this time. 2. Then within 1 second, it had constant velocity. So 3. And this is where we have a constant velocity, then decelerates uniformly, okay, and finally decelerates, okay, for 3 seconds. We are not told that it decelerated to rest, no, and finally decelerates uniformly for 3 seconds. So 3 plus another 3 must give us 6. And this is the point where the body decelerates uniformly. So when you compare what we've done to all the 4 graphs here, I think the best one, you see, answer 1 and then 4 looks similar, but let's look at it well if it's in line with what we have. Okay, uniform acceleration occurring within 2 seconds. Question 1, answer 1 has it. Then constant velocity occurring within 1 second. Question 1 also has it. Then uniform deceleration occurring within 3 seconds. Question 1 has it. Let's look at what 4 has. Answer 4. Uniform acceleration occurring within 3 seconds. That alone defeats the details as we were given. Class, are you okay? Are we fine?
Yes,
Yes, sir.
All right.
yes.
Then the next question. Question 3. The graph below represents the motion of an object traveling in a straight line as a function of time. What is the average speed of the object during the first 4 seconds? What is the average speed of the object during the first 4 seconds? And when you look at the graph, we know for sure for displacement time graph, our average speed V average will certainly be equal to total distance over total time. So what is the total distance within the said time? For the first, when you look at the graph, the body's displacement or displacement increased steadily from 0 to 2. Then from 2 to 4 seconds, then from 2 to 4 seconds, the body was stationary. That's why we have 0 gradient. So it means that within the set time, 0 to 4 seconds, the total distance there is 2, or the total displacement 2, within a total time of 4. And this is 0.5 meter per second. That is the average speed. All right. Question 4. Question 4. Which statement about the movement of an object with 0 acceleration is true? 1, the object must be at rest. 2, the object must be slowing down. 3, the object may be speeding up. Then 4, the object may be in motion. Eva, are you there? Hello, Eva. Hello. Hello, Eva. Oh, Eva is not there. Nana Yao. Nana Yao. Oh, I want to pick the view of Caleb. Caleb, are you there?
Yes, please.
What was your pick in question 4? What was your the answer you picked in question 4?
This is the one we got over the weekend.
No, what meaning you are not following, Caleb. You are not following the discussion. Okay. All right. So then let me move on. Which statement about the object, the movement of an object with 0 acceleration is true? Yes, I want one of you to share whatever you put down with us. Let's have a volunteer. Okay, Eva. Eva, I called you over and over. Go ahead.
Yeah.
Eva, go ahead.
Okay.
Jojo, mute yourself. Jojo, Eva, go ahead. Hey. Eva can't hear me out. Okay, let me take over. You see, let me take over. When we talk about acceleration, you see, we said acceleration of a body is equal to change in velocity over time. So acceleration belongs to change in velocity, meaning the object must be in motion and its velocity must be changing before we can talk about acceleration, implying that when a body is stationary or at rest, you can't talk about acceleration because it has no velocity for it to even change to give you acceleration. So when a body is at rest, we can't talk about acceleration because it has zero speed. Okay, so when the acceleration of a body is zero, what it simply means is that there is a velocity, but there is no change in the velocity because A is equal to V final velocity minus initial velocity over T. If A is zero, then it simply means that final velocity is equal to initial velocity. And if final velocity is equal to initial velocity, class, does that imply that the body is at rest? Does the situation imply that the body is at rest if V is equal to U? Is a question to the class.
No.
No. It
No.
means the body is in motion, but the only thing is that its velocity is not changing. So the obvious answer is that if acceleration is zero, it means the object may be in motion. Okay, we can't give it to at rest. We can't give it to at rest because at rest simply means that its velocity is zero. Okay, but once the body's velocity is constant, it means it is in motion, but the initial velocity is equal to the final velocity. Please, any question? All right, then we move on to question 5. Which graph represents an object moving at a constant speed for the entire time interval? I take it again. Which graph represents an object moving at a constant speed for the entire time interval? Let's look at the graphs individually. Please, in analyzing a graph, okay, you need to look at what kind of graph is this? Is it displacement time graph? Is it velocity time graph? Is it acceleration time graph? We are talking about moving with a constant speed. Constant speed during the entire time interval. And if we look at displacement time graph and velocity time graph, in fact, I think, let me mute everybody before. When I want you to come in, you unmute.
Yeah.
All right. So for constant speed, displacement time graph, ST graph, constant speed must be this. Meaning along the straight line, will have the same value of slope, which is equal to the speed or velocity. For velocity time graph, constant speed must be this. Okay, so for displacement or distance time graph, constant speed must be this. For velocity time graph, constant speed must be this. Let's look at the various options. Answer 1 is out of the equation because answer 1 indicates that the motion is what? Yes, the body is. Yes, I need a response. Answer 1 indicates that the body is. Somebody to answer. Hello, who is answering for me? Okay, the answer 1 indicates that the body is at rest or stationary. The second answer indicates that, okay, the body's distance covered increases with time, but non-uniformly, not in equal intervals. That is what it means. So here we can only find the instantaneous speed. 3, the third one shows that the body moved with a constant or uniform speed for some time and then was stationary. Okay, then the fourth answer is this. The fourth answer is this. So clearly the answer is option 4. Class, are we fine?
Yes.
If you want a further explanation, let me know so I can quickly do that to move on. So for uniform speed or constant speed throughout the entire time interval, it must be any of this. So this is, you must expect one of these in the 4 options. Unfortunately for us, the option 4 is here. All right. Question 6. Hey, question 6, I was surprised some of you got that wrong since you've done measurements. I'm sure you did fundamental quantities, base units, and then derived quantities and units. Which term represents a fundamental unit? And we have watt, Newton, joule, and then meter. Obviously, it is the fourth one, meter. That's why I said I was a bit surprised. Question 7. An object travels for 8 seconds with an average speed of 160. Okay, so we have T is equal to 8 seconds, V bar or V average equal to 160 meter per second. The distance traveled by the object is, since average speed, V bar is equal to total distance over time, it means that the total distance will be equal to V average by T. So 160 times 8 must give us the total distance traveled. And I think here it is the option 3, 1,280 meters. Question 8. an object is displaced 12 meters to the right. Let me draw. An object is displaced 12 meters to the right. This is my right. And then 16 meters upward. It is also displaced 16 meters upward. This is 12. This is 16. The magnitude of the resultant displacement is, okay, so here, you see, this is movement, okay, along two different directions, okay, right and upward, okay. If it is in the same direction, maybe an object is displaced 12 meters to the right, and from there was displaced 16 meters to the same direction. If the situation had been this, okay, since the displacement is along one direction, the resultant will be addition of them. We only add the two displacements, but here the two displacements are along the horizontal plane and along the vertical plane. So you must find the resultant using vectors. I think you will understand better when we come to vectors. Okay. So once they are along two planes, horizontal and vertical plane, it means that the angle between the two displacements must be 90, because this because if this is horizontal plane west, east, and then the vertical plane north, south, the angle between these two planes is 90. So once we have 12 acting along this and then 16 acting along, it means the relationship between the two displacement is equal to 90. And to find the resultant, you need to use Pythagoras theorem to find the resultant. So it means that we'll solve it, but I'll explain better when we begin vectors. Okay. Okay, what I'm saying is that if the two displacements were acting along the same plane, either horizontal plane or the vertical plane, solving this is addition. So a body moves 12 meters horizontally, 12. And then from there, it also moved another 16 meters horizontally, meaning the same direction, in one direction. So if it is like this, then the resultant or the total displacement, okay, the displacements are in one direction. So the total displacement here would have been 12 plus 16, giving us 28 meters. 2, if the two displacements are along the same plane, but one of the displacement is to the right, another is to the left. Okay, in this particular situation, yes, the displacement is along the horizontal plane, but one is due east and the other is due west. Here, the resultant displacement here would be equal to, we always subtract the lesser one from the larger one. So since 16 in this direction is greater than 12 in this direction, the resultant will be 16 minus 12, which is 4. so the resultant would act in the direction of the 16-meter one. Okay, this is what we are talking about is similar to tug of war. During tug of war, okay, one group of people pull the whole thread or rope in one direction, and another group of people also pull it in the other direction. Whilst they pull, you see, the larger applied force always wins. So you realize that if force A is greater than force B, then force A would pull them in the other direction. Okay, so when they are along the same plane and one is greater than the other, the larger one always wins. So in this situation, the resultant would act in the direction of the 16-meter one. Please, are we okay? Class, are you fine? Now, if they are acting in two planes, and two planes, this is what I mean. West, east. West, east is one plane, horizontal plane. West, east is one horizontal plane, and then north, south is another vertical plane. So we have a body moving 12 meter due east along the horizontal plane, and another body moving 16 meters along the vertical. Okay, so the body is moving along two planes. To resolve it, the angle between the horizontal and then the vertical plane is 90. Once this is 90, equal vectors, we can bring this and then put it on the horizontal one. Okay. And we can find their resultant using Pythagoras theorem. Please, when we come to vectors, you understand better. But it's like we are looking for the hypotenuse. The hypotenuse, if it is x squared will be equal to this side, maybe a, this side is b. So a squared plus b squared. Therefore, x squared will be equal to a is 16 squared plus b, which is 12 squared. Okay, square 16 and then add it to 12 squared and then give me the final answer. What is 16 squared plus 12 squared? Yes.
100.
Come again. 400.
400.
Thank you. Therefore, x is equal to the square root of 400, which is 20. So the resultant of such interaction will be 20 meters. But as I said, this is anavectors. When we get there, you enjoy. But this is just the surface of it. Is that okay?
Yes, please.
Okay. Question. Where are we? Question what? Class, which question are we on?
Question 8. 8.
Okay, 9.
9.
Question 9. All right. An object moves a distance of 10 meters 10 meters in 5 seconds. I think we have solved a similar question. Okay, an object moves a distance of 10 meters in 5 seconds. The average speed of the object is, so it's about average speed, and average speed is total distance over total time. So clearly it's 10 over 5, which is 2 seconds. All right. Question 10. The graph following represents the relationship between velocity and time So meaning it's a velocity time graph for an object moving in a straight line. What is the acceleration of the object? So let's look at the graph. It's a velocity time graph. And if you have a velocity time graph and the gradient, the slope is 0, what does it mean? If you have a velocity time graph and the slope is 0, what does it mean? Class, anybody, quick one.
Acceleration is also 0.
Acceleration is 0. So if you understand this, within one second, you've picked your answer. What is the acceleration? Once it's a velocity time graph and the slope is 0, acceleration is also 0. Pick one. So when you understand the concepts, in fact, it is so easy. So please, at your free time, revise, go through the graph of motions. Go through the graph of motions and then understand, so that when you are given a situation, you can easily apply. Okay. All right. Question 11. 11.2 is a very simple question. Acceleration is a vector quantity that represents the time rate of change in O, I, momentum, B, velocity, 3, distance, 4, energy. So velocity, changing velocity over time, or changing time, right?
Yes,
I put this question over to one of you, and I'm going to pick out the name and then call. Asian, are you there? Let me hear your voice. Asian. Hey, Asian has no voice. Okay, Asian, this question is for you. A moving body must undergo a change of I, velocity, I2, acceleration, 3, position, 4, direction. Asian, what's the right option here for a moving body? To denote that a body is really moving, what is that obvious change that must indicate that yes, the body is moving? Must it be its velocity, its acceleration, its position, or direction? Okay, anybody else? Please, if your hand is up, go ahead and answer. Position. Yes, if the body's position doesn't change, it doesn't mean that the body is in motion. Well, a moving body can have, okay, the same velocity. It can also have 0 acceleration. Okay. So what actually indicates that a body is moving must be a change in its position. If the position is not changing, there's no movement. All right. Then 13. I think this question 13, a lot of you were worried. So let me quickly give a sketch. Then we look at it. It floored a lot of you looking at the answers marked. So we had 1, 2, and then 3. So 2, 4, 6. And this is a speed time graph. Then we have 1, 2, 3, 4. 1, 2, 3, 4. So 0, 5, 10, 15, 8. 1, 2, 3, 4, 5. Okay. I must create another one. So 20, 25. Then we have A passing through the graph A from 0 passing through 15. Then the graph B due to 10. So this is graph A and then graph B. The question is that the graph shows the relationship between speed and time for two objects, A and B. Compared with the acceleration of object B, the acceleration of object A is, so we are comparing the acceleration of A to B. Okay, so compared with the acceleration of object B, the acceleration of object A is 1/3 as great. So it means that you are saying A is 1/3 as great as B. Then 2, twice as great. 3, 3 times as great. And then 4, the same. So let's find the acceleration of A and B and compare, right? So acceleration of B. On a speed time graph or velocity time graph, how do we determine the acceleration, class? On a velocity or speed time graph, how do we determine the acceleration? Yes, Paulette.
Change in velocity over change in time.
Good. Or I want another view. On a speed time graph, how do we determine the acceleration? I want another view. Anybody? Yes, Leslie.
Please, final velocity minus the initial velocity over time.
It's not different from what Paulette said. I want something different. Or please go ahead if you have, if your hand is up. Okay, go ahead.
Sir,
Or
please, the slope.
the
Find the
slope.
slope.
Slope of what? Slope of what?
Graph A.
So the slope of the speed time graph or the velocity time graph. Is that okay? So it means if you have a speed time graph or velocity time graph and you are looking for the acceleration, find the slope. So Paulette and Leslie, technically or yes, practically, this is what I expect. So let's find the slope of B. So the slope of B gives us the acceleration of B. Okay. Slope of B. Slope, you only pick any 2 points on the straight line. I can pick this and this, or this and this, and this. And since it's a straight line, I must get the same value to be the slope. So if I'm picking this and this, slope will be equal to the change in the vertical over the change in the horizontal. So what's the change in the vertical? Maximum value 10 minus the minimum value 0 over change in the horizontal. Maximum time minus the minimum time. So 4 minus 0. So I have 5 on 2. And what is 5 on 2? 5 on 2 is the same as what? 2 points.
5.
2.5 meter per second squared. And this is the acceleration of B. Okay, then acceleration of A must also be equal to the slope of A. Now, you see, over here, I picked this and this. And once it's a straight line, I could have also used this 2.5 for the slope. And I must get the same value. Okay, let's see if I had used these 2 points. Change in the vertical 10 minus 5 over change in the horizontal 4 minus 2 minus 2. This is 5 on 2. The value is the same. So once it's a straight line, it doesn't matter where I pick my point for the slope. Meaning that, Paulette, mute yourself. Look at, for A, class, open your eyes here. I cannot pick, for A, I cannot pick this and this. I can use these 2 points to find the slope because the change in the vertical I can determine 20 minus 0. But the change in the horizontal, I cannot precisely get the time for this point. I can't tell, and you can't guess. So I cannot pick this and this for the slope because I cannot determine the time to this point. Class, are you following? Are you following what I'm saying?
Yes, sir.
Yes, please.
So I can use this. But then once it's a straight line, I can pick 2 other points. And the easiest way out is to pick this and this, because I can accurately get the time for this point. So if I pick these 2 points, I have 15, the maximum vertical 15 minus 0 over 2 minus 0 for the horizontal. And this will give me the slope of A. So I have 15 on 2, which is 7.5
7.5.
meter per second squared. Now, let's compare 2.5 and 7.5. If you divide 7.5 by 2.5, this is equal to 3. So it means that acceleration of A is equal to 3 times the acceleration of B. The acceleration of A is 3 times the acceleration of B. And that's the answer, the fourth option. However, If we are comparing the acceleration of B to the acceleration of A, then it will be 1/3. Acceleration of B is 1/3 the acceleration of A. Please, are we okay? Class, are we okay?
Yes, please.
Yes, please.
So if you are given the problem, take your time and analyze. It's a very good exercise. At least it will help you understand the basics to move on. Is that clear?
Yes,
All
sir.
right. If you have any question, ask. Now, let's quickly look at a question I posted. Question 2. And I'm
Please
reposting.
go over the slope K part.
Okay. So somebody is requesting for going over slope of A. Okay, so this is A. The graph A. The graph of A. To determine a slope, once it's a straight line, any 2 points picked must give you the same value of the slope. Okay, meaning that I can pick this point and then this point, or this point and this point. But then, per what we have, this is not a properly grilled line graph. So you can't pick anyhow to get your value because this is unscaled. So even though I can pick any 2 points to calculate my slope, but because this is not properly scaled, I cannot also pick anyhow per this situation. So I must, if I pick the beginning point and this point, I can determine the slope of this graph. Because if I should pick this point and then this point, I'll have problem determining the change in the horizontal because I cannot get the time for this point. For the point, the maximum point, I cannot get this time. And I can't guess that this can be somewhere 2 point close to 3. You can't make that guess. So the obvious one to approach to use is to pick this point and then this point because you can easily trace the time. So if I pick these 2 points, then slope of A is equal to the change in the vertical. The maximum vertical value is 15 minus the minimum vertical value is 0 over the time. Maximum time 2, minimum time 0. And so I can easily find the slope. Audrey, are you okay?
Yes.
All right. So I'm resending the question to the platform. I want you to write it down. So let me give you 2 minutes to write the question in your notebooks. Then we'll look at it. So class, I'm sure you are through with copying the question. Are you? Hello?
Hello.
Are you done writing?
Yes.
No, please.
Okay, then if you haven't, hurry up and then let's look at it. All right, so a body starts from rest and travels to a distance 120 meter, 300 and 180 meter in successive equal time intervals of 12 seconds. In successive equal time intervals of 12 seconds. During each interval, the body is uniformly accelerated. Okay, so it covered these distances. First part, it covered 120 within equal time interval, so 12 seconds. Then second part of the motion, it covered 300 meters. Also within 12 seconds, successive time intervals. And then the last part of the motion, which is the third part, it covered 180, also within 12 seconds. Okay, and during each interval, the body is uniformly accelerated. Okay, there is a uniform acceleration there, either a positive or a negative. I calculate the velocity of a body at the end of each successive interval. Calculate the velocity of the body at the end of each successive interval. So we were told that the body starts from rest, meaning for the first part of the motion, the initial velocity u is 0. The final velocity, we don't know. So, and we are asked to determine the final velocity, calculate the velocity of a body at the end of each successive interval. So we are determining the final velocity at the end of each successive interval. So I want you to help me determine the final velocity for the first part. That is your challenge. Let's determine the final velocity v for the first part of the motion. Start work. And I think 1 minute, 2 minutes, 1.5 minute, 1.5 minutes must be used for this. Class, start work. Angel, are you here?
Yes.
Okay. Are we through? Class, are we through? Hey, I gave you 1.5 minutes. So Eva cannot hear.
120 meters per second squared.
You had 120.
Yes.
Okay. Any seconder? Angel. Della. Colette. Erefua. Jojo. Nana Kwame. Roll call. All right. Your time is up. Let's see. If
I had
yes, Adam. What have you had? Okay, so this is it. One way to determine this. Okay. I can use average velocity. The concept of average velocity. Total distance over total time taken is also equal to initial velocity plus final velocity over 2. I can use this to find V. So I have total distance during the first part, 120 over time of 12 is equal to 0 plus V over 2. V is equal to 120 over 12 by 2. Okay, this goes into 12, 6. 6 goes into this 2. Or this is 10. Or this is 10 times 2. 20. Adam, did you say 120?
Yes. Yes.
Plan B. Plan B. Another way out. I know from the second equation, ut plus half at squared. And I need acceleration, the acceleration to find V. If I'm to use 1 or 3, equation 1 or 3. And since the body starts from rest, u is 0. So this part goes to 0. This part is 0 because the initial velocity is 0. So I have S is equal to half at squared. I have S. S is 120 is equal to half by A by 12 squared. So I have A equal to 120 by 2 over 12 by 12. 12 squared. So this goes into this. And what will be left is 10. So I have 20 over 12. And what is 20 over 12? This is 1 point what? Twenty over 12.
1.67.
6 what?
1.67.
So that will be the acceleration. So if this is the acceleration, then V is equal to U plus AT must give me the final velocity during the first part. So 0 plus 1.67 by 12. What is 12 times 1.67?
20.
90.04.
20 points. So whichever way you look at it, you must get the same value. Please, are we okay? Now, we are looking for the second, the final velocity for the second part of the motion. Now, once it's a continuous motion, the final velocity of the first part, becomes the initial velocity for the second part of the motion. I take it again. Because it's a continuous motion, okay? The final velocity of the first part of the motion becomes the initial velocity for the second part. So use that application to find the final velocity for the second part for me, V2. And then let's see. Start work. I take it again. It's a continuous motion. So the final velocity of the first part becomes the initial velocity for the second part. Okay, so it means that U2 is equal to 20. What about V2? Are we true? So using average velocity for the second part of the motion, it means that S2 would also be equal to U2 plus V2 over 2 times time. Or if we are to divide through by T. So for the second part, distance covered 300 over time 12 is equal to the initial velocity of the second part of the motion is the final velocity of the first part, which is 20 plus V2 over 2. Therefore, V2 is equal to 300 on 12 times 2 minus 20. This and this is 6. So 50. 6, 5, 50 minus 20. So we have 30 meter per second. Please, did you get this? Did you get
Yeah.
30? The ladies, let me hear from you. Wallet, Audrey,
Yes.
Della. Okay. So that's it. That's it. And we can also use the same. You can play around. You can even find, okay, the acceleration during the second part of the motion. And to get the acceleration, S2 is equal to U2t plus half AT squared. You know S2. S2 is 300. 300 is equal to U2 is 20 by 12 plus 12 by A times 12 squared. Okay. So this, you can use this to find it. Okay. So 300 minus, this is 240 is equal to half by A. What is 12 squared? Is that 144?
Yes, please.
Divide that by 2. Divide that by 2.
Please, 72.
So this is 72. So we have 72A. A therefore is equal to 60 over 72. And this is 0 point what?
83. 0.8.
So 0.833 meter per second squared. Okay. So once there's the acceleration, then V2, using the first equation of motion, V2 would be 20 plus 0.833 times 12. We just want to confirm. Okay. We just want to confirm using the equation. So this times 12, which is this? So 30. We have. So you can just play around. Class, are we all following?
Yes, sir.
Yes,
Okay,
please.
so go ahead and help me determine the final velocity for the third part of the motion, V3. And help me determine A, the acceleration. So V1 20, V3, V2 30. Help me get V3. Thank you. So the motion starts from rest 0, then V1 20, then we had V2 30. So the maximum velocity obtained, okay, is 30 because from there was a uniform deceleration. So 12, another 12, so 24. Another 12, 36. Okay, now what was the acceleration obtained in the first part? The motion starts from rest and then accelerated uniformly. So this is the first part. Then from there, the body was also accelerated, uniformly accelerated. Please, what is that value we had for A1? And what did we get for A2? What did we get for A1? Class, what did we get for A1? Hey, are you people there?
1.67 meter per second.
1.67. And what did we get for A2? What did we get for A2?
Unmute.
What? Hey, Frida, I thought you were coming to answer. What did we make for A?
83.
Let's give prompt feedback, please. So it means that the slope of A is greater than the slope of A2. So A2, if we are drawing, okay, this must give us a lesser slope. We can't have the same slope. So if I'm choosing this to be my slope, then I'll push the time a little bit to this part so that I have, instead of this, I can have this join into this. So I can draw my, like this. The whole reason is that the acceleration represents the slope. So once the accelerations are different, they shouldn't have the same slope. Okay, this must be steeper than this one. So when you are drawing, these are the factors you need to put in place. You don't just draw anything. You must factor all that. Then the third part, there was a uniform deceleration. So the final velocity is 0. So there's the motion, the graph of the motion. Any question? Then use the graph in II, this graph, to calculate the acceleration during each time interval. That's the same value we've had, but let's confirm. Let's use our graph to confirm. Okay, so the acceleration of the first part is the slope. is the slope of the first part of the motion. Change in the vertical, so 20 minus 0 over 12. And this is 1.67 meter per second squared. Okay, then the acceleration of the second part must be the slope of this. So 30 minus 20 over 12. So we have 10 over 12. And that must give us 0.833 meter per second squared. Then the acceleration of the first part of the last part, A3, must also be the slope of this part. Okay, must be the slope of this same part. And this is a deceleration. So the final is 0. The initial is 30. And so using that, we have 0 minus 30 over 12. And we need to have negative 2.5. So using the graph, using the equations of motion, I think the value is the same, isn't it? Or you have some a clarification to be given. Please, if you have any question, bring it up and then let's see. Any question? All right. Now, this is your own work. I'm sending you a work set right now. You are going to think through it, and when you finish, forward it to me. Now, we are not ending it, but you are going to think through this question and answer for me to mark for you. So I've sent the question. Let's go through the question together. Etienne, I forwarded the question to you. Please, let's go through the question. A body at rest. A body at rest is given an initial uniform acceleration of 8.0 meter per second squared for 30 seconds, after which the acceleration it's a continuous journey or motion, after which the I'm coming. For 30 seconds, after which the acceleration is reduced to 5.0 meter per second squared for the next 20 seconds. The body maintains the speed attained. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Draw the velocity time graph of the motion and using the information given above. Okay, so draw the velocity time graph of the motion using the information given above. A, using the graph, calculate I, maximum speed attained during the motion. The maximum speed attained during the motion. Then II, the average retardation as the body is being brought to rest. Then III, total distance traveled during the first 50 seconds. Then IV, average speed during the same interval as in III. This is your problem to think through for, and I'm giving you 10 minutes to quickly do this. Start work. I'm giving you 10 minutes. Or let me give you 13 minutes. Use 3 minutes to read through, think through, and then 10 minutes to solve the problem. And then afterwards, we'll discuss. Okay, class, is that okay?
Yeah,
And I
please,
want,
what proof?
pardon?
My network. Yeah. Sir,
I've,
please, my
I've,
network.
I've
problem.
forwarded a question on the platform. There's a question on the platform. You are solving it now. Okay. And you have 13 minutes. Start work.